Hello, welcome back. Here we are, and we're going to be adding some enemies. This game, as it stands, is kind of boring. There's not really much point to it. You just kind of move back and forth and don't really do much of anything, even though it looks pretty with these nice Microsoft-provided graphics. We're going to add some enemies, and that's going to spice things up a little bit. They're going to fly across the screen, try to hit me, that kind of thing. Ultimately, I would like to have patterns of enemies. As you guys might know, I was one of my jobs I actually had in the industry was creating AI for games. One of the games I worked on was Quake 4. I made some of the AI for this game. It was a lot of fun. Just as a diversion, I figured I'd throw this video in. I'm not going to play through the whole thing, but it was kind of fun. So we had various enemies that we could fight, and you can kind of see them jumping back and forth here and doing various things, stepping side to side, shooting at you, all kinds of stuff. So obviously the game that we're making now is much more simple than this, but you know, it's the first step towards making games like that. So let's go ahead and get started. So what we're going to want to do is, first off, I'm going to close this debugging, and I'm going to go back to shooter, and I am going to create a new class. So Shift-Alt-C creates my new class. I'm going to call it enemies.cs. And in enemies.cs, I want to put in my standard Microsoft using libraries, so using system, framework, and framework.graphics. Actually, I screwed up a little bit here. I don't like the fact that I called it enemies, so I'm going to change this because the deal is I want this to basically represent each one to represent its own enemy. And so I just did a quick rename to enemy. So I want to go ahead and add some instance variables here. This is what it's going to look like. An enemy animation to represent the animation that I'll play as it goes across the screen. A position for the enemy, whether or not it's active. What the health is. Damage. The value, the score value that's going to give to the player. Here we've got a property width that we're going to set with a get on return enemy animation.framewidth, and height return enemy animation.frameheight, and then initialize and update. So that's basically it. Now next I'm going to need to fill in the initialize and eventually the update. Initialize is going to be pretty straightforward. We're going to set the enemy animation, we're going to set the position, we're going to set whether or not he's active, set the health, set the damage, set the speed, and set the score. Now inside the update loop, we want to keep moving the enemy towards the player. So you got to ask yourself, how are we going to do that? Well, we're going to say position.x equals minus equals enemy move speed. Minus equals, remember, is the same thing as saying position.x equals position x minus enemy move speed. Minus equals is just another way of saying that. And then we're going to update the position of the animation, update the animation itself, and if it has passed the screen or if its health is 0, then we're going to actually deactivate the particular enemy in question. Draw is very simple. We're just going to simply draw it, passing in a sprite batch. In order to pass in that sprite batch, I need it to actually be called with a sprite batch, so it can draw the sprite batch, and there we go. So that's about it for now for the enemy. The game 1 is what's going to keep track of all these enemies that are on the screen. So we want to add some new code for enemies. And we're going to basically make an array of enemies. In this case, we're going to use a list because the list can dynamically grow. It can go up and down. If there's only one in there, that's fine. It'll just hold one. If there's a whole bunch, it'll just keep adding on there. We're also going to create a time span for when the enemy should be appearing and what the previous time span is so that we can remember how long it's been since we spawned an enemy. So we want to initialize these sort of randomly. I'm going to go ahead and add some initialize code. Basically say initialize our random number generator as well as initialize our enemy list, and set our time to 0 and our enemy spawn time to determine how fast they're respawning to from seconds 1. I'm also going to want to load the animation inside of load content. Say enemy texture equals content.load mine animation, and the mine animation was provided to us again by Microsoft. We've got that right here, and that's split up over 1, 2, 3, 4, 5, 6, 7, 8 different sprites basically. And remember, we're using the animation class that we had made last time to pull this all off. And we're going to need an add enemy method that can be called from time to time when it's time to spawn an enemy. So I'm going to go ahead and make one. Call it add enemy. It's going to create a new animation for the enemy. It's going to initialize the enemy to the given texture and the position on the screen. And then it's randomly going to generate a new position for that enemy, which is going to be somewhere between the width of the screen and a random.next 100, and somewhere along that, if you're looking at this game playing screen here, somewhere along this wall it's going to generate that enemy. And then it's going to initialize with that enemy animation in that position and add it to our array, our list. We're going to update. We could just go ahead and put a bunch of stuff inside of update that updates enemies, but that doesn't really make sense. We want to have one function that updates all of our enemies. So we're basically going to say spawn a new enemy every 1.5 seconds, which is what this logic does. Total game time minus previous spawn time. If it's greater than enemy spawn time, then it will add an enemy. And then we're going to update all of our enemies, calling update on each one, and that's going to actually move them across the screen, remember. So now all we have to do is call update enemies from somewhere. Well, a good place to do that from is from the update. So we're going to go ahead, and after we're done updating the background, we're going to update the enemies. We're going to draw the enemies after we draw the background, but before we draw the player. Just going to draw the enemies there, and then I'm going to go ahead and run this. So start debugging, and voila, we have enemies on the screen coming towards me, barreling down the road, and they're even playing their animations. Now you'll notice that they do not collide with me yet. That's something we're going to fix in the next step. You'll also notice that they are drawing underneath the player. That is because I'm drawing the player last. I'm drawing the background, then the enemies, then the player. So that's probably what we want. So next we want to add the ability for things to collide with the world. So this is kind of complex, so I'm just going to jump right into it. But basically, we want to have a collision detection routine, and this is what it's going to look like. We're going to call it update collision, and we're going to basically use some built-in intersect functions to detect if two objects are overlapping. We're going to create one rectangle for the player. That's how we do that there. Then we're going to do a collision check between the player and all enemies. So we're going to go on a for loop throughout all the enemies, creating a new rectangle for each enemy. Then we're going to see if it intersects that enemy. And if it does, we're going to subtract health from the player based on that enemy damage. And when the enemy collides with the player, we will destroy it. We need to add this to the update. And go ahead and call update collision down here. Remember way back in, I don't know, video 3 or so, week 1 or week 2, I talked about how collision updates were part of the physics update loop. Well, here we are in the update loop of game1.cs, and basically we're saying update player, We're getting the input, we're updating the player logic, we're updating the enemies, then we're updating the physics, and then finally we're doing the base, which will update the draw. So this is update collision, and now if I run the game, we should see enemies disappearing because of the following code that I put in here. Update collision, which creates two rectangles on the screen, and it just basically checks for if those rectangles are intersecting. So if there's a rectangle here for the player and there's a rectangle down here for the enemy, as soon as those two rectangles collide, that will be registered as a collision. I'll start debugging. And there we go. We're indeed getting those collisions to happen. It's almost like you're catching them. Whee! Okay, so that's great. One thing to note is that the collision stuff is also going to be necessary for what we're going to do next, which is shooting. So let's go ahead and move right into shooting. Shooting is going to be fun. For shooting, we basically want some bullets to come out of the player. The simplest way to do this is just going to be to make a steady stream of bullets coming out of the player. And that's exactly what I'm going to do. So, to start things off with, we're going to make, as you guessed it, a new file. And this one's going to be called projectile. So I'm going to Shift-Alt-C it. I am going to type in projectile. I'm going to include all the stuff that I have to include. For my using section, there's a whole mess of instance variables that I'm going to want. I've got my texture, my position, my damage, my viewport, so I know the boundary of the game, properties width and height, my initialize, my update, and my draw. I'll start out with the initialize like I usually do. Initialize function is pretty simple. It's just going to take the texture, assign it to that local, and remember, we're going to have a whole bunch of projectiles going across the screen. So each one is going to have that texture, but it's also going to have a position that can change over time. Now we just stubbed in an update function down here, but we're going to replace it pretty much immediately here with the ability for the projectile to move across the screen to the right. So the ship is here, it's shooting here. So, you know, bang, 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 and it just kind of keeps shooting. And once it's off the screen, then we actually deactivate it down here. Now we need to have a draw method so we can actually draw the projectile. And we're done. That's basically the projectile class that we need. We need to spawn these from the enemy, and that's fine. And also, I'm sorry, not from the enemy, from the player, which means we're going to have to make some changes over in player and game.cs. Well, first of all, in game1.cs, we're going to want to add some instance variables to represent the projectiles that are currently in the air. So this is going to be our list of projectiles. Remember, that's our array that kind of dynamically grows. This is also the fire rate to the player that I'm going to code up in here, and that's the projectile texture. So as usual, we got to update our initialize so we can initialize that stuff. We're going to say new list projectile. Fire time equals timespan.from seconds. And we need to load this content. Now luckily, Microsoft has provided us with a laser beam right there. Kind of hard to tell, but that is in fact a laser beam. Nifty, huh? We're going to go ahead and load that laser beam inside of load content. We're going to say projectile texture equals content.load texture2D laser. So we want to create a method, just like we did for add enemies, where we're doing that at certain times. We're going to add projectiles at certain times. So we're going to make an add projectile method, which is going to create a new projectile, initiate it to the right projectile texture, and add it to our list. Next, we actually want to add these. So in update player, I'm going to say If gametime.total game time minus previous fire time greater than fire time, then add projectile to the front and center of the player. So player.position plus new vector 2, player.width divide by 2. So similar also to how we update enemies on a regular basis, we want to update projectiles. So near where I have our update enemies, I'm going to put an update projectiles. And this is going to go through our entire list of projectiles and remove them if they're no longer active. And remember, they're not going to be any longer active if they're off the screen. That's very important, otherwise we're going to end up getting a memory leak because, well, not a memory leak, but we're going to hit our memory limits basically, because eventually these things just are not going to die and they'll just go off and eventually we'll run out of memory. So very important that we actually remove these when they're done. We also need to make sure that's actually called. So just like we called update collision, I'm going to call update projectiles. And then we need to make sure that we can draw the. So after we draw the enemies, I'm going to draw the current projectiles. So I go through the whole projectiles list, and do projectiles I.draw sprite batch. Now we're not done yet because we haven't done anything to check for if projectiles are colliding with the enemies. So we want to add that to our collision check. Couldn't find update collision for a sec, but just remember you can always go to this little menu up here and you can go to update collision that way. So after we do our collision between the players and enemies, we're going to have a whole section that does our collision between the projectile and the enemies. And this is going to go through all the projectiles, then it's going to go through all the enemies, creating a new rectangle for each projectile, and then testing if it's actually hit that rectangle for that particular enemy versus each one of the projectiles that exists. So this is called an inner for loop. This is a nested for loop that basically is going to go for each projectile. It's going to go through all the enemies. So that's basically an n-squared algorithm is what we call it in computer science, where we're actually going through all the enemies for each of every projectile. So it's a pretty expensive function, but this is also a fairly simple game, so it should be no problem. Alright, I think that's pretty much it. Just to go over the changes, what we've made here is we've made a projectile.cs file, put our initialize, update, and draw in there, and our various things. We're adding projectiles at a rate inside of here, calling add projectile every once in a while. We're calling update projectiles to manage the ones that are in the air, and then eventually we're drawing them, and we're also doing our collision detection. So I'm going to go ahead and run it to start debugging. And I've got lasers. No sound effects yet or anything like that, but I do have lasers and it's pretty cool. So we've gone pretty far today. We've got a game that's almost fully functioning. This should be enough to get you started on your projects. You can start to use this code. I will be uploading the code that I have so you can use that as a start. But I'm hoping that you followed through this with me so you get a sense of what each of these methods does, and you can get a start on your own games that are based off of this. Alright, good luck and talk to you next time.